This is part 2 of section 4.4. We are solving equations with exponential and logs. And so this one's a little bit different. We have multiple e values, whereas on all the previous problems we only had one. And it's not like they're like terms because they have different exponents. So I can't just combine these and make it go away. So what I need to do is I need to think all the way back to chapter 1. What we have here is something that is quadratic in form. We have a 0. We have 3 things either added or multiplied together, added or subtracted together. We are looking for a constant in this position. And whatever this is, we want to have the same thing here, but the exponent needs to be doubled. So we want this exponent to be the double of this exponent. And so if we have that, then we have something that's quadratic in form. And your substitution, your u value is going to equal whatever is right here. So e to the 2x. So, and remember that this means that u squared is e to the 4x. Squaring both sides, we have the rule where a power raised to a power, you multiply the exponents together. 2 times 2 is 4. That's where that comes from. So let me rewrite this using u instead of e to the 2x. This would be the same thing as u squared minus 3u minus 18 is equal to 0. Now I want to solve this for u, and then once I know what u equals, then I can go back to this substitution and then continue. Well, what I have here is a quadratic that is pretty easy to factor. If I think of two numbers that multiply to negative 18 and add to negative 3, negative 6 and positive 3 work. So this factors as u minus 6 times u plus 3, and that's going to equal 0. Now set each of these equal to 0. And you find that u is equal to 6, or u is equal to negative 3. Okay, so I know what u is. Now I have 2 more equations to solve. The first thing I need to do is I need to undo this substitution, and I'll have e to the 2x is equal to 6. And then I will also need to solve e to the 2x is equal to negative 3. Now this problem is very similar to this problem, or maybe a little bit more like this one, but it's easier than that. All we need to do here is to take natural log of both sides. And remember, I'm choosing natural log because this is an e. If this had been a base of 2, I would have done log base 2, something like that. Most of the time, you're going to have an e value in here, so don't worry about that too much. And that includes once you get into calculus. Natural log and e are really important in calculus. So if I take the natural log of both sides, remember that this is a number, even though I don't necessarily know what it is. The natural log and the e undo each other, so I have 2x is equal to natural log of 6. Divide both sides by a 2. Remember, you cannot divide the 6 and the 2. This is a number, it's not 6. And although we do have a property that involves division, it involves division of the argument, not a division with a natural log in the top and a number in the bottom. Okay, so this is x is equal to natural log of 6 over 2. So x is approximately, let's do this, natural log of 6, and then divide that by 2. And you get approximately, that's going to bump up the 9, which is going to bump that up. So it's approximately 0.90. Remember that if you're asked to round to 2 places, you need to have a 0 here. You can't just drop it. This indicates how precise your rounding was. So this is at least one of my solutions. It works. Now let's do the same thing here. Natural log of e to the 2x is equal to natural log of negative 3. So I get 2x is equal to natural log of negative 3. Divide both sides by 2. And you get x is natural log of -3 divided by 2. So natural log of -3, and you get a domain error. Okay, what happened here? This is kind of like the analogy would be when we have a square root of a negative number, and we know that doesn't make sense in that world, so we reject it. The same thing happened here. We cannot take a log, any bet log of a natural number, of a negative number. So this just gets thrown away. This is an impossible solution. My only solution to this problem is 0.90. Okay, so now the previous page we started off, we were doing exponential. Our original equations had exponentials in them. Now on this back side of this, we're going to be dealing with logarithmic equations. And here's where we often end up using our log properties. One of the ways we can do this is, notice we have different bases now too. That's important. What we generally want to do is we're trying to get our x's out of the argument of whatever equation we have. Just like on the previous page, we needed to get our exponents, we need to get our variables out of the exponents. So one thing we need to remember a lot is if you have one logarithm equal to a number, that is the most basic form of a logarithmic expression. And so we can always switch, go from log form to exponential form. Now look what happens here. This is going to get my x out of this argument. Remember, when we switch back and forth, you take this value and move it over here, and it bumps this number up. So what I end up with, by switching this into exponential form, I get x is equal to 5 to the third power. Well, that's easy. I can figure 5 to the third power very quickly. It's equal to 125. Now, I did not need to do an approximation here because I got an exact answer. Okay? Now we're going to do something very similar right here. Our argument is more complicated than just an x. So once we get to basically this step, we'll have a little bit more algebra to do. But we're going to be fine. Okay? So again, I'm going to get this out of the argument of the logarithm by moving this 7 over here, and this is going to become my exponent. So I will have x plus 2 is equal to 7 to the -2 power. Remember, negative exponents mean that whatever this is moves down into the denominator, and then it becomes a positive exponent. So I have x plus 2 is equal to 1 over 7 squared, which is, of course, x plus 2 equal to 1 over 49. Now to get x alone, you know what to do. We need to subtract subtract 2 from both sides. So we get x is equal to 1 over 49 minus 2. And I'm going to use my calculator here to get this done. 1 over 49 minus 2 is negative 97 over 49. And if they want the exact answer, that's what you would give. And I personally would prefer this type of answer. But if the computer asks you for an approximation, remember that you have a conversion button. You hit that button and it will give you the decimal approximation. So if that's what we're asked for, and to 2 decimal places, this would be negative 1.98. And there you go. Okay. All right, so this is definitely a more difficult problem. We still want to try to get our x out of this argument. And we have several options here, okay? I have the opportunity to take this third power and move it up here. Remember, we have that property. Here's my property list right here, where I can take this number in front and move it up to become an exponent. I have that option. This is also a multiplier, which means I could divide both sides by 3, and that will work too. Now notice right here that I have log base 2 of 4. There's no x here, there's no argument and no variable in my argument. So I need to ask myself, can I simplify this? Remember that if we can write something so that the base of the log and the base of the exponential are the same, it equals the exponent. So I'm coming over here, let's imagine coming over to scratch paper. I have log base 2 of 4, and this is the same thing. Can I rewrite 4 as a power of 2? Yes. This is log base 2 of 2 squared. These two are the same. That means that is my answer. So log base 2 of 4 is the same thing as 2. So what I have here is 3 log base 2 of x minus 1 is equal to 5 minus 2. So 3 log base 2 of x minus 1 is equal to 3. Now, when this divides evenly, I'm definitely going to use that. I'm not going to take this and make it an exponent, especially when my life looks pretty easy if I just go ahead and divide. So what I really have here is log base 2 of x minus 1 is equal to 1. Now what were we doing here? We ended up with a single logarithm equal to a number. And that means once you have a single logarithm equal to a number, you can switch to exponential form. This 2 comes over and it becomes 2 to the first power. So I have x minus 1 is equal to 2 to the first power. Okay. Now, so 2 to the first power is 2. So I have x minus 1 equals 2. And then I end up, by adding 1 to both sides, I get x equals 3. Okay. Now, I forgot to mention this up here. I really should have. We started off with x values and logs. We do need to make sure that these values are in the domain. This would require me taking a logarithm of a positive number, so that's good. Right here, I really should have checked to see that once I plugged in this value to make sure I got a positive number here, which is a good way of doing the good reason for doing the approximation. If I do negative 1.98 plus 2, I'm going to get a positive answer. So this makes sense. It is in the domain. We're good. For this one, for this log, it's going to be perfectly okay because there's no variable. Right here, if I take this 3 and plug it in here, I'm going to have log base 2 of 2, which is perfectly legal. This did not give me a 0 in the denominator. So this is my answer. And they're definitely not going to ask for an approximation here because you got an exact answer.